Palletizing is one of the most common applications of industrial robots. Robot palletizers are used in a variety of manufacturing industries, primarily to lift heavy payloads, reduce cycle time, and improve plant productivity. In this example, we'll show you how easily and quickly you can simulate several different events involved in loading the pallets and process it through a conveyor system. In this scene, we have three sets of inbound conveyors. The first one feeds the wooden pallets, the second one feeds the pails, and the third feeds cases to be loaded into the pallets. The sequence of operation involves the robot to pick the pallet, place it to the outbound conveyor, load the products, layer it with a slip sheet, and finally the pallet moves through the outbound conveyor. The robot will alternate between loading pails and cases. Now let's see the benefits Process Simulate provides in analyzing and simulate this operation sequence. First, you will notice the feature we refer to as part appearance. Appearances will allow us to easily program the order in which we want the objects to appear in the scene. This feature helps us to continuously feed the pallets and products into the simulation model without having to queue them. You can see that objects are generated and then removed from the scene automatically. If you are familiar with existing robotic simulation tools, in the past, sequencing the pallets and their appearance in the scene required complex user inputs. Now let us test some fault condition to check that some of the critical robot execution criteria are met. First, we'll test what happens if we starve the inbound conveyor that's feeding the pallets. You can see that now the conveyor has stopped loading new pallets into the system. This could be a common real-world scenario if the supply of new pallets is disrupted because of events outside of this scene. After all the available pallets are processed, the robot gets a signal from the conveyor through a proximity switch that the conveyor is empty. Since the robot got a signal that the conveyor is empty, it stopped immediately. Next, let us test some of the operator prompted fault condition. Here the operator used the hold button to perform maintenance. We want to validate that pressing the hold button stops the robot at the end of its current path. We can see that it does stop. In another scenario, what happens if the operator opens the gate accidentally? You can again see that this caused an emergency stop condition. The robot stopped immediately. Lastly, we want to check the swept volume of the robot to make sure that there is enough clearance between the robot and nearby equipment and peripherals, typically called pinch points. We can do it using the swept volume command. You can check the volume the robot occupies, and if needed, you can use measurement tools to scale key pinch points. You have seen how using Process Simulate you can easily define the processing sequence of a palletizing operation. Check for various fault conditions and ensure that you met all your safety criteria.